MAT1, where we're going to start talking about principles of square roots. This is where you have x squared is equal to some constant value. Now, if you recall back when we talked about perfect squares, that there's always a plus and a minus, whether it was factoring or we talked about square roots being plural. If you have to introduce the square root symbol into the problem, you have to have a positive answer and a negative answer. So x squared equals 25. To solve for x, you could do this as the difference of perfect squares, but now this principle says you can just take the square root of both sides. And x is equal to 5, but it also has to be equal to negative 5. If you wanted to solve this by factoring, then you're getting a x plus 5 and an x minus 5, and you set both of those equal to 0 and solve for x, and you get the two answers. But in order to take the square root principle here, you have to isolate the x squared. So in my next example, we're going to have to divide over the 3. Oh, and before I forget, when you're doing your homework, if you happen to see this symbol when you type it into the text box to enter something, you can use that symbol instead of, if they say separate your answer with a comma, you can just go plus or minus symbol and then the 5. So like I said, next example, we'll have to divide out the 3. X squared equals 2. Take the square root of both sides. You have plus or minus the square root of 2. No decimals. They're going to be asking for exact values. Here we need to get the x squared by itself, so we're going to have to subtract over the 2, divide over the negative 5. X squared equals 2/5. This is fine. Take the square root of both sides. X equals positive or negative 2/5. Now, they probably may not accept that answer because, again, you have to rationalize the denominator. This is really the square root of 2 over the square root of 5. So we need a perfect square in the denominator, so think about multiplying top and bottom by 5 over 5. That way this will be 25, and the square root of 25 is 5. And that way the square root's only on the top. The 2 times 5 is square root of 10. 4x squared plus 9 equals 0. Subtract over the 9. Divide over the 4. And now we're going to take the square root of this. Now in real numbers, it was declared that you cannot take the square root of this. But remember, we talked about imaginary numbers. We can now take the square root of a negative, and that's an I. Square root of 9 is 3, square root of 4 is 2, plus or minus. So now we'll be able to solve everything. If it says f of x is equal to the binomial x minus 2 squared, find f of x equals 7, that just means send the x minus 2 binomial over to f of x, set it equal to 7, and solve. So to solve this, we're going to start from the outside. Now we have to take the square root first, because the minus 2 is on the inside of the parentheses. So x minus 2 equals plus or minus the square root of 7. We'll add over the 2, sneak that in front of the plus or minus, and there will be my answer. So those are the two answers. 2 plus the square root of 7, 2 minus the square root of 7. All right, next example. Let's solve this for x. Again, start from the outside to the inside. We have to subtract over the 7. That gives us 26. We now take the square root of both sides. X minus 5 equals a positive or negative square root of 26. I can't simplify this. Add the 5 over, sneak it in front. There's my two answers. So notice that all the work being done here is the PEMDAS rules working backwards. All right, please excuse my dear Aunt Sally. Here's my x on the left side. I start with any adding or subtracting on the outside. Then I take care of any multiplication or division. Then I take care of the exponent. And then I'm inside the parentheses, basically starting all over. So again here, outside to inside, get rid of the minus 11. Add 11 to the other side makes it 18. Now we go up the list. Any multiplication or division on the outside? Yes, a multiplication of 2. Divide the 2 over. X plus 3 squared equals 9. Now get rid of the exponent of 2. Take the square root. x plus 3 equals a positive or negative 3. Whoop, time out. Notice that we were able to simplify the square root of 9. So now you literally have to write two equations from here. One with a plus 3, one with a minus 3. We can't leave this as a positive or negative 3. We can when it's a square root, because we can't simplify that any further. So we'll write two equations, one positive, one negative for the answer. Subtract over the 3's. We get a 0 and a negative 6, and there's my two answers. X equals 0, comma, negative 6. We do not leave the answer as negative 3 plus or minus 3. They will not accept that. You can simplify those to specific values. All right, next example. Outside to inside, add over the 1. We get 38. Divide over the 4. Now, at this point, do not reduce this. Notice that my denominator is a perfect square, so don't reduce it by 2 because then I'll have to rationalize it. My next step is to take the square root here, and I will have plus or minus the square root of 38, and the square root of 4 is 2 in the denominator. I'll add over the 1, put that in front of my plus or minus, and there's my final answer. Okay? All right, next, completing the square. I don't know about you, but this seems very easy to solve quadratic equations. What you do not want to do is to FOIL this out. Add the 7, subtract over the 33, set it equal to 0. Realize, oh, I cannot factor this. These equations are very easy to solve because there's one x in the equation. Whenever there's one x in the equation, you simply undo everything you encounter. So now I'm thinking, what if we go back to a trinomial, back to when we were factoring, and we run into a trinomial or quadratic equation that we were not able to factor. Remember, we had some that were prime. So if we tried to factor this, there are no two factors of 7 that subtract to be an 8. 7 and 1 add up to 8, but they don't subtract to 8. So that's a problem. So here's what we're going to do. You get rid of the minus 7 because it is the problem child here. This value does not allow us to factor it. Therefore, get rid of it. How do I get rid of it? You always add the opposite of the constant to the other side. So I'm going to add the 7 over, and at the same time, I'm going to put a plus blank on both sides. To remind myself, I want to find the perfect constant that allows me to factor this. Now, how do I find that perfect constant? That's step 2. To find that perfect constant, you take the b value. That's what's multiplied to x to the first power. You take the positive 8, you divide it by 2, and you square it. So positive 8 divided by 2 is a positive 4 squared is 16. Now, a lot of authors of books will tell you to put 16 in both of those blanks. That's fine, but I'm going to show you a shortcut here. The reason we want 16 is because now this is going to factor to what two numbers multiply to be 16 and add up to 8 is going to be this plus 4 and plus 4. Well, technically, that gives you plus a binomial squared here, which gives us only one x in the problem. So since this plus 4 is what I found earlier, and I need that to factor this, don't put a 16 here. Put the plus 4 squared. So when you read this, this is how we're going to do this step. I take the positive 8 and I divide it by 2. It's a positive 4. Always include the sign. Positive 4 squared is 16 because this positive 4 goes into my two binomials. That becomes an x plus 4 squared. So now what I'm going to do is once I get the plus 4 being squared and the 16 over here, I'm going to jump down to this step. This will always happen. So if it's always going to happen, we don't have to write it out twice. Now I have 1x. I'm going to undo what I see after I take, so here's again my shortcut, just so you understand. Here's a term being squared, here's a term being squared. Take those terms and put it into the parentheses being squared. We solve it now for x. Take the square root of both sides. X plus 4 equals a positive negative 23. Subtract over the 4, sneak it in front of our plus or minus, and there's our answer. Completing the square is very efficient when solving for a quadratic equation when there's a 1 in front of your x squared. Super efficient. All right, let's try another example. X squared minus 6x minus 2 equals 0. Obviously, you can see there are no two factors of 2 that will subtract to be 6. Get rid of it, add it to the other side. Once I add it over, again, remember, I'm going to put in plus blanks over there with it. Now, let's talk about how to fill them. Half of a negative 6 is a negative 3 squared, which is 9. We don't want 9 and 9. Now, this term squared, those build my binomial squared. It's going to factor to x minus 3. We're just going to hightail it to x minus 3 squared. 2 plus 9 is 11. We're 2 steps from being done. We take the square root of both sides. X minus 3 equals a positive negative square root of 11. We add the 3 over, sneak it in front of the plus or minus square root of 11, and you're done. Now, again, you can calculator check this. You can take 3 plus the square root of 11 and store it in for x. It's going to be a crazy decimal. You type in the left-hand side, and it equals 0. So if the plus sign works, the minus sign also has to work. Because remember, the principle of square roots rule said that if you have to have two answers, one positive, one negative, and that's the plus or minus sign. All right, let's try this one over here. There are no two factors of 3 that add up to negative 10, so we subtract over the 3. We put in our plus blanks with that. All right, talk your way through this. Half of a negative 10 is a negative 5 squared is 25. Now, build your binomial square. That's the two terms being squared. X minus 5. That's why we want to include the sign, because it becomes the sign in our binomial. That's squared. Negative 3 plus 25 is 22. 2 steps from being done. Take the square root. Can't simplify the square root of 22. We keep the plus or minus. Add the 5, sneak it in front. X equals 5 plus or minus the square root of 22. And again, there's your calculator check. 5 plus the square root of 22. Store it next. Remember the store button's above the on button. Type in the left side. X squared minus 10x plus 3. Hit enter. It equals 0. Now you know both answers are correct. All right, next. Oh, wait a minute. These might be a little more difficult because notice that our middle term was even. It was easy to divide by 2. Now my middle terms are going to be odd. Don't panic. Do the same steps. There are no two factors of 6 that add up to 3. Subtract over the 6. Put in your plus blanks. Now remember, what's half of a positive 3? Not 1.5. 3 halves. Square it to get 9/4. Don't panic. I tell you right now, you are not going to work with fractions. There's fractions here, but you will do no fraction work. All right, so the binomial, x plus 3 halves squared. Done. Now remember, I said there's no fraction work here. Negative 6 plus 9/4. When you have an integer over here, whether it's positive or negative, it's like having a mixed fraction. You take the denominator, you multiply it to negative 6, which is negative 24, and then you add it to the 9, and that gets you negative 15. I don't care what you say, I did not work with fractions. I took a 4, I multiplied it to a negative 6, I took that answer and I added it to 9. None of those numbers are fractions. All right, we're going to take the square root of both sides. Oop, we got a negative here, so we're going to take out an I. Square root of 15, square root of 4 is 2, with your plus or minus. Subtract the 3 halves over, sneak that in front of the plus or minus, and there's your answer. Now, you can also check this, but again, you have to be in complex mode, that a plus bi. So here's negative 3 divided by 2 plus I square root of 15, close it off, divided by 2, stored it for x. I typed in x squared plus 3x plus 6, it's equal to 0. I know I'm right. I don't care what this decimal looks like. That doesn't concern me. I just want to check it in the original problem. Okay, next. Again, minus 2 doesn't work. Add it over. Put in your blanks. Here we go again with this odd number. Half of a negative 9 is negative 9 over 2 squared. Okay, that's going to be a positive 81 over 4. My binomial squared, x minus 9 halves squared. Fix my mixed fraction here. 4 times 2 is 8, plus 81 is 89. We take the square root of both sides. We get plus or minus the square root of 89. I can't simplify it. There's no factors. I believe 89 is prime. The square root of 4 is 2. My parentheses are gone. Add over the 9 halves in front of my plus or minus. There's my two answers. Again, calculator check. 9 divided by 2 plus the square root of 89. Divided by 2, store it for x. I type in the left side. X squared minus 9x minus 2. It does equal 0. I'm happy. So it doesn't matter if you have an even or an odd b value. We can still do completing the square. All right, let's see if they can throw anything more difficult. Oh, yes, they can. Now notice there's no 1's in front of our x squared. Now they're putting 2's and 3's. Don't panic. All right? If I attempted to factor this, I would have to do what times what is 2 times negative 5. Okay, that's negative 10. There are no two factors of 10 that will add or subtract to be an 8. Okay, so now the two numbers that are not allowing me to factor this are both the 2 and the negative 5. All right, that's my problem. So what we have to do now is to get rid of both the 2 and negative 5 because they're not allowing me to factor this. All right, so what I'm going to do, well, I have a multiplication of 2. I have the minus 5. Let's get rid of the multiplication of 2 first. Divide everybody by 2. Don't panic that there's a fraction here. It's okay. Add the 5 halves over to the other side, put in your plus blanks. Remember, don't panic. Fill in your blanks. Half of a positive 4 is a positive 2 squared, which is 4. All right, left side's going to be x plus 2 in parentheses squared. Over here, now the integer and the fraction are just on opposite sides. 2 times 4 is 8, plus 5 is 13. It's equal to 13 halves. Now, my only dilemma here is that the 2 in the bottom is not a perfect square. So I can either fix it now or fix it later when I have to rationalize the denominator. So I'm going to choose to take that 2 in the denominator, multiply both the top and the bottom to get 26 over 4, because now 4 being a perfect square, when I take the square root of both sides, I get x plus 2 equals plus or minus the square root of 26 on the top with a 2 on the bottom. Otherwise, I get the square root of 13 over the square root of 2, and then you got to rationalize it. So you either do it now or do it later. It doesn't matter. Subtract over the 2, and there's our answer. And again, just like we did before, you can store that for x, type in the left side, and you will see that it is correct. You can grade your homework and test. All right, next, 3x squared minus 9x minus 4 equals 0. 3 times a times c, 3 times negative 4 is negative 12. There are no two factors of negative 12 that add up to be negative 9. So divide and get rid of the 3. Oh, another fraction, don't panic. X squared minus 3x minus 4/3 equals 0. Add over the 4/3 and put in your plus blanks. Oh, we're going to get another fraction. Now, what I want you to notice, though, is notice I left a little space here between my plus sign. Why? For the same reason over here. 2 wasn't a perfect square, 3 is not a perfect square, so I'm going to probably have to multiply this to get a perfect square. So I need to put in this blank here first. So half of negative 3 is negative 3 halves squared is 9/4. Okay, so the first thing I want to do is I want to make sure my denominators are perfect squares. So I'm going to multiply this by 3 over 3, which is going to give me 12 over 9. Now, some people say, wait a minute, I just need to add these two fractions together. Why don't I just say, oh, I have to have a least common denominator of 12, because 12 is not a perfect square. So here's a trick. If I make both my fractions with denominators of a perfect square, then when I multiply them together will be my least common denominator, and that will also be a perfect square. So between the 9 and the 4, I need to multiply them together to get 36. That's a perfect square. So this will be multiplied by 4 over 4 and 9 over 9. So 48 plus 81 all over 36 is 129 over 36. Now, I say this to practice this because if you use your calculator will give you the answer in reduced form. And you will not have a perfect square in the denominator. So here's where a calculator is not going to be very helpful. So remember this trick. When you want to have a perfect square in the denominator, make sure both denominators are perfect squares first. Then you multiply the two denominators together to get 36. Then one denominator multiplied to the other numerator, the first denominator multiplied to the second numerator, and there's your new fraction. We'll take the square root of both. We get x minus 3 halves equals plus or minus the square root of 129 over 6. The only factor here is 3 and 43, so no one's a perfect square. Add over the 3 halves, put it in front of the plus or minus, and you're good to go. So please mark this example in your notes about the trick with fractions to get a perfect square in your denominator. Okay, next example, 2x squared plus 5x minus 1 equals 0. All right, there we're going to look at the most difficult things we can encounter. All right, well, I can see this doesn't factor already. 2 times 1 is 2, so no two factors of 2, subtract to be 5, so divide everybody by 2. All kinds of fractions, don't panic. Add the 1/2 over, put in your plus blanks. Again, leave yourself some room so we can make perfect square denominators. Half of 5 halves. Whoa, how do you take half of a fraction? You multiply the denominator by 2. Whatever your denominator is, multiply it by 2. Okay, a positive 5/4 squared is 25 over 16. 16 is a perfect square. Oh, and by the way, 2 goes into 16 8 times. So let's multiply the top and the bottom here by 8 over 8. 2 goes into 16. That's going to be my common denominator. It's a perfect square. Make this one the same denominator. And we're in business. 8 plus 25 is now 33 over 16. We have our binomial squared, x plus 5/4 squared. 2 steps away, take the square root of both sides, plus or minus the square root of 33 over 4. Subtract over the 5/4. We have our answer. 4x squared plus 3x plus 8 equals 0. Yeah, I guarantee there's going to be no factors here. All even factors, and you need an odd factor to get in the middle. So divide everybody by 4. X squared plus 3/4 x plus 2 equals 0. Subtract over the 2. Put in your plus blanks. Again, don't panic with the fractions here. Remember, half of a fraction is to multiply the denominator by 2. So that's positive 3/8 squared, 9/64. Okay, here I might need my calculator because the numbers are getting bigger. I need 64 times a negative 2. That's a negative 128, plus 9 is a negative 119 over 64. My binomial squared is the x and the plus 3/8. Take the square root, don't forget your I. Square root of 119, 119 is prime. Square root of 64 is 8. Parentheses are gone, subtract the 3/8 over, put it in front of the plus or minus. You have your answer. See? You're really not doing fraction work here. Now, what we're going to do next is we are going to complete the square for the world's most difficult problem. We need to solve this right here. And we're going to use the same steps as we did here. What makes this more difficult is we don't know the values, but the steps stay the same. Divide away the a. Ax squared over a, bx over a, c over a, 0 over a. There's my terms. Next thing, get rid of the constant. Subtract it over and put in your blanks. Leave some space in between here because we're going to have to manipulate the denominator to make sure it's a perfect square. Wait a minute. They're variables. How do I know if they're perfect squares? You just have to have that variable squared and you're in business. So here we go. Half of a fraction, multiply the denominator by 2. So that's positive b over 2a, square it, b squared, 2 squared is 4, a squared is a squared. All right, so we have the a. A goes into 4a squared 4a times. So we'll multiply the top and the bottom by 4a. This is just like when we had the 2 and the 16 here. All right, so that's going to give me b squared. I'm going to put the positive term first, then the minus 4ac second, all over 4a squared. And here's my x plus b over 2a squared. Take the square root of both sides, plus or minus. Now, I can take the square root of the bottom because that's one term. That's 2a. The top, you cannot take the square root of these terms because that's technically a binomial. You either take the whole thing or nothing. So I can't say, oh, this will be just a b and I'll put a b out here. Absolutely not. It's a binomial. It's all of it or none of it. So plus or minus the square root of b squared minus 4ac all over 2a. Subtract over the b over 2a, and you've just solved it for x. And ladies and gentlemen, boys and girls, you just created the quadratic formula. The quadratic formula is technically two fractions. A lot of books and a lot of high school teachers will say, oh, this is one fraction, negative b plus or minus b, the square root of b squared minus 4ac all over 2a. No, trust me. You do that, you're going to make simplification errors. You leave it as two fractions, you will never simplify anything wrong. Example time. There's my quadratic formula. I have 4x squared minus 6x minus 9. Now, I'm going to admit it. When was the best time to complete the square? It was when there was a 1 in front of here. I might be able to get away with completing the square is when I want to divide a, and if a divides into b evenly, then it's still easy to do. But since that's not going to happen here, I would get 6/4, 9/4, and I create more fractions. This is why we have the quadratic formula. So you identify your a, your b, and your c, and we plug them all into the quadratic formula as two fractions. And I'm going to explain why you want to do that. Once I substitute in my negative 6 into b, notice that this negative here in front of my fraction is not the same as the negative on my 6. 2 times a, 4 here, Notice that my 6, which was technically negative, but I didn't put a negative here. Why? Because when you square b, it's going to be positive. So why put the negative in? 6 squared minus 4 times a, 4 times c, negative 9. This first part always will be positive. Don't put the sign on it. Okay, the next thing I want you to notice here is that my first fraction is going to simplify. The two negatives will become a positive. The 2 can divide into the 6 3 times. Okay? Now, 99.99% of the time, if this first fraction can simplify, then so will this fraction, which means you're going to be able to simplify this radical and factor something out to the front, some perfect square factor, so you can reduce it. I guarantee it. And it's 99.9% of the time that if this first fraction doesn't reduce, then either will this one. So our focus now should be on the square root. So let's simplify everything. So right now I have 3/4 plus or minus my 2 times 4. Now over something on the top, move this off to the side, and let's simplify this. How would I simplify? Go to your calculator. See, now this is why I don't want you to put a negative 6 here, because if you don't put parentheses around it, you get the wrong value. So 6 squared minus 4 times negative 9 is 180. All right, we can break that down. All right, so here, let's see. Divide that by a 5, you get 36, which is a perfect square. So I'm going to get 6 square root of 5 up here in the numerator. And now, because this reduced by 2, this too will reduce by 2. And there's my final answer. Everybody agree with that? You have to agree. Now, one of the reasons I'm going to try to load up my iPad here to show you why you don't want to have this as a one fraction, because it will throw you off for a loop. Okay? I have seen this so many times. We're trying for preventive medicine here. Okay, so I see this as, okay, negative 6 plus or minus the square root, negative 6 squared minus 4 times negative 9, all over 2 times 4. And all of a sudden I see this. Oh, plus plus, 2 goes into 6 3 times. And now I simplify this. And I get 3 plus the square root of 180, which we now know is 3 plus or minus 6 square root of 5 over 4, and then I see this. Folks, this is a binomial. It's either all of it or none of it. As you can see, my denominator is supposed to be a 4, not a 2. But if they're individual fractions, you can reduce them right away. And if this fraction reduces, this one's going to reduce too. So you know you're going to have to break down the square root of 180. If it doesn't reduce, then you won't have to break down the radical. Nothing's going to simplify. There is a method to my madness. All right, 3x squared minus 5x plus 3, identifying the a is 3, the b is negative 5, the c is 7. I plug in all the numbers. I get a minus negative. Okay, that's going to be plus plus. Okay, nothing reduced, so it's 5, 6. This is a 6. I'm expecting that this won't break down because I was not able to reduce the first fraction. So I go to my calculator. We're going to get 5 squared minus 4 times 3 times 7, negative 59. Okay, so the only thing I can simplify out of here is the negative. We'll call it I, square root of 59, and you're done. But it did not reduce. Next, now what they're going to do is give us difficult quadratic equations that don't start off quadratic. So here we need to distribute the x, distribute the 2, and set it equal to 0. So minus over the 4x, add over the 2. There's my equation. Now you have an option. You can do complete the square, or you can do the quadratic formula. Well, since we're in the quadratic formula section of 11.2, we'll do that. So 1, 1, and 2, so negative 1 over 2 times 1 is 2, plus or minus 1 squared minus 4 times 1 times 2. Okay, this one I don't think I'm going to need a calculator. 1 minus 8, we're going to get a negative 7. Take out the I, and there's my answer. Over here, we need to get the x's out of the denominator, so we multiply everybody by x squared. So x squared times 2 is 2x squared. Here we'll cancel an x to give us 7x. Here the x squareds cancel to give us minus 4, and x squared times 0 is 0. So a is 2, b is 7, c is negative 4. Go to our quadratic formula. We have negative 7 over 2 times 2. Nothing's going to simplify, so therefore nothing should simplify over here as well. So we're going to get negative 7 over 4 plus or minus something over 4. Go to the radicand. Let's type it into your calculator. 7 squared minus 4 times 2 times the negative 4 is 81. Wait a minute. The square root of 81 is 9. My square root disappeared. Whoa. That can happen. All right. So since the square root canceled out, I have 2 answers that I can now simplify. So negative 7 fourths plus 9 fourths. Well, negative 7 plus 9 is 2. 2 fourths is 1/2. That's one answer. And then negative 7 fourths minus 9 fourths is negative 9/16 fourths, which is negative 4. So those are my 2 answers for x. So technically what happened is I went so fast that I forgot to check to see if this can factor. You could have factored and solved this. So if the square root completely simplified away, then the equation was factorable. But we still got the answer anyhow. And that wraps up 11.1 and 11.2.